Good morning, IB Math. All right, moving on, we're going to be doing, we just finished 6H. Now we're going to do 6I, and this topic is area of triangles. The area of triangles. Now we know one formula from geometry, nice, well-behaved formula. Base and height. Area equals 1/2 of the base times the height. But in trig, we don't often know that information, the height or the base or something like that. So we need to create other formulas for the area of triangles. So there are two other formulas that we should know for area of triangles. One of them is, so this is the regular formula. One of them we should know from honors geometry deals with the sides of a triangle. If I know that this is length B and A and C, I can use Heron's formula to find the area of the triangle, where area equals the square root of the semi-perimeter S times S minus A times S minus B times S minus C. Oh, that should be a lowercase a, little a, side lengths A, B, and C. S is the semi-perimeter, which is add the side lengths up, divide by 2. Okay, so this is from the honors geometry, from regular geometry, where I know all of the side lengths. And I can use Heron's formula. The semi-perimeter times the semi-perimeter minus A, semi-perimeter minus B, semi-perimeter times C, or this formula. But what I'd like to do now is I'd like to look at a trigonometric version of the area formula of a triangle. So again, I want you to consider a triangle here. And I want to focus on this angle, I'm going to call it alpha, and the height here. And if I know, for example, this side length is C, and this side length is A, and the whole side length here is B, well, I know area equals 1/2 of the base times the height. But what if I don't know the height? What else can I do with this? Well, the height, I can find out what the height is just by knowing this angle and these two side lengths, because the sine of any angle is the opposite over the base. Now for the base here, now be careful, this B is the whole side length there. But to find this height, I have to ignore this part right here. So I'm really just talking about, I'm going to put a little bit of a little X right there, just that part right there. In other words, the height is going to be X times the sine of alpha. This little length here times the sine of alpha. Which gives me area equals 1/2 of the base times the height. Again, I don't like this X right here. This is the concept. Let's look at a slightly better way of thinking about this. So, given a triangle, area is going to equal 1/2, and let me draw a triangle here for a moment. There we go. So here's my angle theta. Here's my side length C and A and B. 1/2 of BC sine the side across from this, I should have written that as A. That's angle A, angle A. All right, let's take a look at some examples of this. Suppose I've got a triangle, and let's say that this angle here is 22 degrees. This side is 17, 25, and well, let's just kind of leave it right there and find the area of this triangle. All right, so area is going to equal 1/2 of 17 times 25 times the sine of 22 degrees. Using the calculator, open parentheses, 1/2 17 times 25 times the sine of 22, and I get that the area, I'm writing the word area because if I do capital A here I'm going to get confused, 79.6. All right, so as far as the area of a triangle doing the trig goes, really that's pretty much all there is to it. We're going to see some complicated figures and diagrams here. Let's do a tough one now. Let's do a difficult one. Suppose I've got some sort of crazy shape. And I'm going to say that this is a right angle here, and this is 5 and 12. This is a 120 degree angle, and this is 18. And I want to find the area of this triangle. Well, I could break it into two different triangles here, couldn't I? If I drop this side right here, this is a nice, well-behaved triangle. This one's very easy to do. If I call this, let's say I call this X. So we're going to find the area of triangle X. It's going to be 1/2 of the base of 12 times the height of 5, which is going to be 30. Now, what about this triangle up here? Well, in order to find this triangle up here, I need to know this length right here. Oh, I wish I hadn't called it triangle X now. So I need to know this, how long this part is right there. Well, let's see. If I know this is 5 and 12, what can I call that right there? Let's call this side length A. So I want to find the length of A, and I know that, well, let's see, how am I going to find this length here? First, let's find one of these angles, or I could use Pythagorean Theorem on this, right? Pythagorean Theorem would work nice and well behaved on this. So 5 and 12, A is going to be 13. What is I need to know this angle inside this triangle here, so I know that this side is going to be 13. I need to know the angle inside the triangle. This angle. Well, the whole thing is 120. Let's see if we can find this angle here. I'm going to call it theta. To find theta, angle opposite and hypotenuse, I know that the tangent of theta is the ratio of the opposite over the adjacent side. So the tangent of theta equals 5 over 12. Take the arctangent. Second tangent of 5 divided by 12 is 22.6. So how much is the angle inside that triangle there? 120 minus 22.6 is 120 minus 22.6, 97.4. All right, so now let's focus on this big triangle over there. So I'm going to just draw the big triangle. This other triangle, if we called this triangle X, we could call this triangle Y. So as I look at this triangle, I've got this and this and this, and I know that this is 13 and 18, and the angle inside we just discovered was 97.4 degrees. So the area of this triangle, so now we're going to find, this is triangle Y, remember. We're going to find the area of triangle Y. And here's where we're going to use our trig, finally. It's going to be 1/2 of 13 times 18 times the sine of 97.4. All right, 1/2 times 13 times 18 times the sine of 97.4, 116.03-ish. 116. So from here, we know the area of triangle X is 30. The area of triangle Y is 116.03. Add them together, and the area of the whole shape, 30 plus 116 is 146, whatever the units were, squared. All right, so there we have finding areas of triangles. What I'd like you to do now is I want you to do assignment I. So do the homework assignment 6I, which is on page 398. And I want you to do problems 1 through 6. And they get tricky, and they get difficult, and they get kind of weird. Gosh, it seems like every one of these is a little bit different from the other ones. Focus on the triangles, pulling it apart, making the triangles, and doing each of the triangles separately, just like we did that last weird shape. Really take them apart, and I think that'll help you. All right, guys, good luck. Do assignment 6I, and then we'll be moving on and looking at some more trig tomorrow. Talk to you again soon. Bye.